All right, so we're going to draw the slope field of this particular equation. The first thing we're going to draw in is our x and t axes. Like so. And now we're going to work out what the value of the derivative is at some certain test points. Now you'll notice that I won't fill in little dots on all of these, but we'll do about 9 of these points per quadrant. So our first thing to do is obviously dx dt at 0, 0. That's obviously 0, right? Dx dt at 1, 1. That's 2. Dx dt at 2, 1. That's 4. And you can see where I'm going with all of this. I've just got to go ahead and do that for all of these points. I'm not going to bother to write them down anymore because the multiplication is actually simple enough to do in my head. Multiply the 2 points together and multiply it by 2. That's all I'm doing. So what I firstly note is that if either x or t is 0, so that's on the axes, my derivative will be 0. So I can go ahead and fill in, I can draw little lines which have the appropriate slope. So at the point, so here at 1, 0, I draw a line which has slope 0. I can quickly go ahead and fill all of those in. And it's always a good idea to firstly look for these null lines or lines of 0 derivative. Next, I'm going to sketch in the line at this point. It's supposed to have slope 2. Now, slope 1 would have a 45-degree angle. Slope 2 would be more than that, obviously. So it would kind of look like that. Now, kind of looks like that is sort of good enough for our purposes when we're hand drawing these slope fields. 1, 2 has slope 4, which is obviously twice as fast, so we just try and draw it at a much steeper angle. 2 times 2 times 2 is 8, so that's going to be nearly vertical as we're drawing it. And obviously, it's getting very difficult to hand draw lines with gradient 4, such as here, and lines of gradient 8, which is there. So try and do the best we can. Now, you note that this quadrant here is the same as this quadrant here, because in this quadrant, both x and t, they're both negative, so the minus signs are going to cancel. So I can fill in this quadrant fairly quickly. And note that I'm just trying to get these slopes close enough relative to one another. So I carefully drew this one with less of a slope than these two. I made sure that these two roughly had equal slope, and this one was steeper. Here and here, one of x or t are negative, so they are going to be sort of symmetric. And obviously, the minus sign is just going to reverse the direction of the derivative, so or the slope. So, for example, 1, 1 is going to have slope minus 1, 1 will have slope minus 2, so that looks like this, right? Essentially mirroring this. And based on that mirror symmetry, I'm going to just fill in the other points here. this is going to replicate this empty quadrant here is going to replicate that one, or you can consider it the mirror of this quadrant. So I'm just going to go ahead and sketch that in as best I can. And that's what my slope field for this equation is going to look like if I sketch it by hand. Suppose that we've got an initial condition. Let's say we're given an initial condition here approximately. Where's our solution going to go? Well, our solution is going to sort of be pushed up like this. Remember that the slope field is kind of always tangent to a solution curve. So if I had an initial condition down here, my solution would be flat. It might grow like this. Right, that's what my solution might look like. That's if I started out here, right, that's what my solution curve would look like, assuming that t increases, because it's sort of supposed to be physically time.